Hello, students, and welcome to our algebra lesson for today, November 17th. And first, we'll start with answering a prompt about a question about listening skills. So important. If you've got great listening skills, you'll have many friends and you'll go far in life. So that's our do now. Our objective will be to think about how we can look at real world events and represent them graphically. So, our essential question is, how do I describe and create graphs that represent real world events? And what is the role of domain and range in real world scenarios? So, we're going to talk a little bit about that. Our assignment will be to watch the video on describing real-world graphs, and we'll complete the assigned pages. There are 2 pages today. And for our exit ticket, I'm going to ask you to name 2 events. So you're going to come up with these on your own that can be described and modeled graphically with graphs. So you're going to describe 2 events on your own. We have a 2-page homework number 2, on real-world graphs, and I want you to make sure that your relations and functions dictionary is complete. We need that uploaded by Wednesday, and then you will have a Wednesday assignment that will count for your grade and for attendance. So for you today, I thought this was a beautiful spot. I thought, wouldn't it be nice to do our algebra lesson here in this place? And we can imagine working here bundled up with a hot cup of cocoa. And I can imagine that it could be in Connecticut somewhere, maybe even nearby. We do live in a beautiful, beautiful area of the state. So I just thought how fun it would be to hold class there together. That would be a lot of fun. We can imagine. So we have this do now prompt. We have a model for active listening called EARS, where E stands for making eye contact, A is for acknowledging that we are listening and asking open-ended questions of the person we're listening to, reflecting their feelings back to them and saying in our own words what we heard them say and confirming what they're telling us. So that is our EARS model for active listening. Active listening will take you a long way in life. It's a great skill to have. And my question is, how does acknowledging and asking open-ended questions help you to actively listen? What is the big deal with this second part, the A in EARS? How could that help you to be an active listener and help you to gain more friends and accomplish more in life? So as promised, there is our exit ticket where you will describe 2 events that can be described and modeled geographically. So let's take a look at our lesson. Our topic today is real world graphs. Okay, so we've got this graph here. Now, before I get to that graph, I want to look at something here. Many, many students, I've said this yesterday, I'm going to say it again today, and I will probably say it before we're done with this unit. Many people look at something like this and they say, oh, that's a graph. They call it graph paper and they think they're looking at a graph. No, that's actually graph paper. And if I do this, let me get our color of the day. If I do this, thicker line, okay. I make a line like that. I make a line like that. And I'm going to label them. This is going to be my x-axis, and this is going to be my y-axis. Okay, and I take another color, and I draw something like this. This dark reddish purple line. This is the graph. Okay? This whole thing, the orange X and Y axis on the grid, that whole thing is the coordinate plane. And I think by not making that clear, I do you a disservice. So as we talk about graphs, I want you to remember this is what we're talking about. Let me get a highlighter and I can even highlight it. This is what we're talking about. That's the graph. That is what we are going to use, or something that looks like it, sitting on a coordinate plane that we will use to describe these real world events that we are talking about today. So let's get back to the lesson. So we've got this crazy graph over here, a lot of zigzagging up and down. First, you want to look at the x-axis and the y-axis. Always look at the labels of your graph first. So look at and there's usually a title. So this one does not have a title. It should. Look at the title and labels. Okay, so we're talking about the x-axis. And the y-axis. Okay, so it says the graph shows the height of a roller coaster during a single ride. Describe the roller coaster ride. So our x-axis here describes time. Our y-axis describes the height in feet of the roller coaster. Now, we don't have any labels here. We don't know how many seconds or minutes this is, and we don't know how many feet the y-axis is, but we have this general idea of what the roller coaster is doing. So we can say the roller coaster left the gate, and then what happened? So it left the gate, and then it climbed uphill. Before going down a large decline, and that's that. Okay, so then what happens? It climbs up again. Descends, but not as far. And then look what it does in this little section right here. It coasts at a level rate. Then it coasts, I will say, on level. Now, the roller coaster climbs again, but not as high as the first hill. Then it descends. Before coming to a level stop. So that's the story of the roller coaster told in a graph. You notice the graph isn't the coordinate plane, it's not the graph paper, it's the orange line, which I will trace again. See, level up again, lower again. So the shortest hill was actually the middle hill. We can compare them. The highest hill was the first hill. That's how roller coasters get their momentum. Now, so let's think about drawing graphs. How can we sketch a graph for each of the scenarios? So number 2, it says in a single day, it snowed lightly. So all of the graph is one day. It snowed lightly during the morning, then heavily for the rest of the day. That's all. Lightly in the morning, heavily for the rest of the day. Now we've got some instructions. Graph time on the x-axis and total snowfall on the y-axis. So let's label the axis first. Time is our x-axis. Snowfall is the y-axis. So it fell gently during the day, lightly during the day. Well, we assume it started out at 0. So I'm going to start out right in the corner. That's 0. And it snowed lightly throughout the morning and then heavily for the rest of the day. Now, it doesn't tell us to graph until the snow stopped. It just says one day in a single day. So that's our graph. That's the real world scenario of the snowfall that was described in that story. So let's try another one. Mia bought a painting. Now, these paintings are sometimes very, very valuable. When I was in law school, I had a couple of my friends studied the law behind art and auctions and insurance and all that stuff. So I know a little bit about this. So Mia bought a painting. The value of the painting dropped by 25% after 1 year, then increased in value over the next 5 years, reaching a value that was twice what she paid for it. Graph time on the x-axis and the value of the painting on the y-axis. So let's label the x and y-axis. Time, and usually students, you will graph time on the x-axis. That's very, very common. And value is on the y-axis. So let's think about this. So she didn't buy it for 0, so it would not make sense to start at the lower left-hand corner. So we're going to have to start somewhere along here. This is an estimate. We can start there, but it dropped by 25%. So 1/4 of the distance between the origin and this dot I just made would be about here, and that's got to be 1 year. So if this is time in years, this would be 1 year, 2, 3, 4, that will be 5 years. So it dropped 25%, about that much, in the first year. But over the next 5 years, it reached a value that was twice of what it was. So I need a dot that's going to be about up here. So I'll put that, and I need that to be at 5 years. So I'm going to put that right here. So over the next 5 years, it reaches a value of twice of what it was. So that's the graph of that scenario. So let's read number 4. Number 4 says a basketball was dropped out of a window on the second floor of a school and onto the concrete below. Each time the ball hit the ground, it bounced and reached a height that was half the previous bounce. It continued doing this until it settled where? On the ground. So we're going down to 0. Graph time on the x-axis and distance from the ground on the y-axis. So let's label our graph before we start. This will be time, and this will be distance from the ground. Okay, didn't quite leave myself enough room to write there, so let me change my color. Okay, so let's think again. What does this ball do? It's dropped from the second floor of the school window. We'll start right there. It does hit the ground. I mean, there's no way this ball didn't hit the ground when it was dropped. But then it reached a height that was half of the previous. So I need something halfway from here to here. We don't have exact, we have very little information on time, but we do know that time passes. So halfway would be about here. Now it's going to hit the ground again. The halfway would be about here. And it's going to hit the ground again. Now halfway would be about here. And each time that it hits the ground, it's going to go halfway until it finally settles on the ground. So that's the real world graph with the story of the basketball. So take a few minutes and I want you to read 5, 6, 7, and 8 and try those on your own. And then come back to the video. Okay, number 5, Jace is speeding on a highway and gets stopped by a police officer. So he's speeding, then he's stopped. He's speeding, then he's stopped. The officer gives him a ticket and he continues on the highway. So we're going to graph time on the x-axis and speed on the y-axis. Be careful, this is a little trickier than you think. So the graph starts out with Jace traveling. So he's not going to start at the origin. He's not going to start at 0. So we're going to have him start out fast. Let's label our graph before we get started. Time on the x-axis and speed, not distance, speed. Be careful on the y-axis. So Jace starts out traveling and then he gets stopped by a police officer. Well, students, you don't go from 90 miles an hour to 0 all at once. Okay, it would be impossible to go like this. That just could not happen. Okay, so let's make this reasonable here. So he probably stopped him fairly quickly, so let's make an angle of about like that. Now he's there dealing with the cop. He's getting his ticket. The cop's telling him, listen, man, you got to slow down. It's not safe to drive like that. The whole time the police officer is talking to him, he is stopped. That's this line I just made right on the x-axis. Now it says he continues on his way. Well, again, just like you can't stop on a dime, you can't go from 0 to 60 in 1 second. So you have to speed up. And let's consider that because he was speeding before, because he got in trouble, he's not going to go as fast as he did before. So maybe he'll go this fast. Maybe that's 55 miles an hour. And he decides he doesn't want to get caught again. He's just going to keep it at 55 miles an hour. So that's Jace's graph. So the next graph is Carlos. Carlos is a running back on his football team. He ran the same number of yards in each of the first 6 games. Okay, this is going to be linear, same number of yards. In fact, it will be a direct variation. We'll understand that later in the term. But he ran the same number of yards in each of the first 6 games of the season. But after the 6th game, something changes. And he did not play for the rest of the season due to an injury. Not good. Oh, no. So he didn't play anymore. We're asked to graph this scenario. We're going to graph games on the x-axis and total yards on the y-axis. So let's label our graph. Games is on our x-axis and total yards on the y-axis. Now, always think about the real world situation. This is a situation where we do start at 0. You don't start at the beginning of your football season with 20 yards or 100 yards. You always start at 0. So we have to start Carlos at 0. And at some point he has, after 6 games, so we could even say, 1, 2, 3, 4, 5, 6 games, he made the same number of yards. Very important. Let me highlight that. He made the same number of yards in each of the first 6 games. That's a steady incline. It's not going to be like the roller coaster graph. That is completely steady from here to here. Same number of yards, but he increased them. Is it 6 yards? Well, then it would increase. 6, 12, 18, 24, 30, 36. Is it 9 yards? 9, 18, 27, 36, 45, 54. Whatever it is, it's a steady increase. Then Carlos has the injury. So what happens to whatever this number is here, it will stay. This is Carlos has this injury, and this is where his I actually don't want to put an arrow on the back. It's not going to go to infinity. So whatever that number is, that's what it will stay for that season, and that's Carlos's graph. So now let's move on to Alice. Alice drives a school bus. On her morning route, she stops at every block to let students on. Now, I don't know what's the matter with these kids. They can't walk a couple blocks to the bus stop, but she stops at every block. So we're going to graph time on the x-axis, and we're going to graph total distance on the y-axis. So let's label our graph. So time is on the x-axis, and total distance is on the y-axis. So she stops at every block. Now think about this. When a school bus stops, it has to stay still for a few minutes so the student can get on. And the school bus also begins its journey at 0, at point 0. It hasn't traveled yet. So we're going to go a block, pick up a student, a block, pick up a student, go a block, pick up a student, go another block, pick up a student, go another block, pick up a student, and continue on this same trajectory, up, straight, up, straight. Those should actually even be more even. Let me see if I can make that just a little bit clearer. Okay, first block, pick up a student. Second, pick up a student. Third, pick up a student. Fourth, pick up a student. Doesn't say how many blocks, but eventually she's going to get to school. We know that. But that's her graph. So now Ray started his workout by running on the treadmill. His heart, this is about his heart rate, his heart rapidly increased and remained high during his run. After the treadmill, then he lifted weights. His heart rate increased and decreased during the time that he lifted weights. So the information is not incredibly specific, okay? It's going to be a little bit tricky. We're going to put time on the x-axis, and we're going to put heart rate on the y-axis. So it says, now listen, we do not want to start here. Why? Because Ray is not dead. Everybody has a heart rate. It's somewhere. Let's start it right here. And it says it increases rapidly, and it remains high. Oops. Sometimes these are a little tricky to draw. Okay, let's make it increase rapidly and then kind of remain high during his run. And then he's going to lift weights where his heart rate decreases, increases, decreases, increases, decreases, increases, and finally, eventually, he will get his heart rate back to approximately where it was before he started to exercise. So the beginning and end points should be about the same. So here it is, heart rate increasing, staying pretty high. Then during his interval weight training, we have these up and downs till he has his cool down at the end of his workout, and he ends up with his heart rate where it was before he started his workout. Okay, we have Carrie, Luke, and Mason. Carrie, Luke, and Mason. We're going to match some graphs to Carrie, Luke, and Mason's scenarios here. So they each get an allowance, and they each receive the same amount each month from their parents. Well, what did they do with it? Carrie spent a small amount in the first half of the month, and then she spent the rest in the second half of the month. Okay, let's color code these. Luke steadily spent his money throughout the entire month. And what did Mason do? Mason spent all of his all of his money, I think that's a typo, all of his money rapidly in the first half of the month. So, what's your spending style, kids? Can you make the allowance last the whole month, or is it gone in the first week? So, we're going to match each student's spending with their correct graph. So, let's see. Let's look at Mason. He rapidly spends all his money in the first half of the month, and then it's gone. He's at a plateau. Whenever you see something that stops and remains the same, we're looking for a horizontal area on the graph. And here, and let's look at these. We have time on all of them on the x-axis. We have dollars spent on the y-axis. So as the month goes on, for Mason, the money runs out. He spent it rapidly in the first half of the month. And I think this is Mason's spending, this first graph. And then he's done. He's got nothing else to spend. So I think that's Mason. Okay, Luke spent steadily throughout the entire month. So let's find Luke's color. So look at the third graph. I wanted to get that to be Luke's color. Look at this third graph. Luke spent steadily throughout the entire month. That's this third graph. It's rising steadily. This third graph, it's a little bit like when Carlos had the same number of yards in each of his first 6 games. This part of Carlos' graph is a steady increase. And that's what we have here in the graph on the right. So this definitely is Luke's graph. Now, Carrie, on the other hand, she spent a small amount in the beginning of the month, and then she spent most of her money in the second half of the month. Carrie is probably the smart one that knew there was a sale at the second half of the month, so she saved her money so that she would have it when there was a sale on Amazon and she could get everything she wanted cheap on Amazon Prime Day. So she spent very frugally, not very much in the beginning of the month, but then she spent it all, did all her Christmas shopping on Amazon Prime Day when they were having sales. Good for you, Carrie, for being so careful with your money. So that's our introduction to real-world graphs. So I want you to go back to your exit ticket and name 2 events that can be described and modeled graphically. We've had examples with bus stops, heart rate, money, allowance. We had the school bus stopping at picking up students. We had speeding on the highway. So make up 2 of your own and write them in here. Thank you for all your hard work in algebra. I can really tell that you're learning a lot. I'm seeing a lot of improvement, and I'm really proud of how hard you work. So keep up the good job, and I know that with practice, you'll be great.